Young man, do you want to succeed, to expand beyond your horizons? If you want to be free, then you must learn to master yourself, your thoughts, feelings, your body and spirit. Master your subjective consciousness. Every action has an opposite and equal reaction. The world outside of yourself is ruled by those who are not ruled by their base instincts. Young man, go forth into the world after this. Meditate, contemplate, then plan and execute an action towards success. Take a risk, break the rules, and be disciplined within self.
Shout out, shout out, shout out. So, what do we got on our hands? We got superconductivity, direct electricity without energy loss, transforming our world, transforming the way in which we generate energy, dropping the marginal cost of energy down to zero. Free energy. Yes, that's what I'm talking about. I'm talking about quantum computing. I'm talking about all kinds of interesting things that you can get from the maglev perspective. What are the geopolitical conditions that will have to change in order for this to happen? What are the pieces on the chessboard? Blah, 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 all that good stuff, ladies and gentlemen. We are here, most importantly, we are here on a Saturday, clicking that like button, sharing the stream. How's it going, Kaizo? How's it going?
Yeah, it's going decent. Not too bad over here. So we're going to talk about a little bit of the future, what's happening, and how we, as Black or African people, can actually get into the game before it's too late.
Interesting. Okay, cool. So first of all, let's do some musing with regards to the superconductivity, and perhaps let's lay down some facts with regards to something that happened recently, and then maybe we kind of go behind the scenes a little bit in terms of the physics / the engineering of it, like the understanding, the building up of that intuition of this electromagnetic field, right? And the behavior of charged particles within electromagnetic fields, right? And so on and so forth, right? If you're catching my drift. But superconductivity basically is the property of certain materials under certain conditions, okay, temperatures and pressures, to conduct electricity without resistance, without energy loss, right? And it seems to be the case that we have crossed a particular threshold with regards to room temperature superconductivity. Because, hey, we can get certain things like mercury to be superconductors at certain temperatures, blah, 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 right? Lots of interesting things that can be done at certain temperatures and pressures. But how about room temperature, such that in my data center, complex design, right? In complex designs data center, he doesn't have to cool. Okay, he can just drop it in the middle of the desert, let it run. It's just running at Arizona temperature superconductivity. But Kaizo, give us a little bit of an update with regards to the latest. And have you read the paper, right? Let's begin there. You're a PhD in physics, right? You go ahead and give us your credentials, right? And LK99, go ahead, take it.
Yeah, shout out. Yes, I do have a PhD in materials physics. And actually, this sort of research, I was working on thermoelectric materials, which is basically a conversion of heat into electricity, direct conversion. So meaning, let's say you can create a gas cooker that, or any kind of cooker, you put in some kind of heat there, converts it direct to electricity. I was working more on the printed ones, and applications can go into printed windows, rooftops, even your hand and your body, your clothes, right? So you wear a material that basically the body heat in your body and the difference in heat between your body and the environment creates free and unlimited technology, right? So this superconductivity stuff is all within the same logic. You use the same parameters to measure things. You're looking at critical temperature, you're looking at resistivity, and you're looking at, or I guess the inverse, which is conductivity. Now, let me just give the background first of why this new product, LK99 as termed, this new so-called room temperature superconductor is a breakthrough, right? First of all, it's actually really room temperature, 300 Kelvin. That's like 26 degrees Celsius. It is actually room temperature. That's one. Secondly, we have made room temperatures before, superconductors, but at high pressures, which are, again, unfeasible for practical application for most things. Meaning you can't really apply them to transport and stuff like that because the pressures will be too high, right? Or even the grid, things like that, which will cause worse issues. This is the first time the room temperature semiconductor, sorry, superconductor that doesn't require high pressure is also atmospheric pressure. That's more or less the breakthrough of what's happening here.
Atmospheric pressure and room temperature, right? And there's a reason why it's measured in Kelvin, right? Because absolute zero,
Yes,
right, is and you know, negative 270 something degrees of both Fahrenheit or centigrade, I believe, right? So
yeah,
yes. Go
yeah.
ahead.
So, for example, let's say most superconductors are usually superconductive at very low temperatures, close to 0 Kelvin, right? Absolute zero. That's why, you know, it's so difficult to get there, because application wise, it's expensive to cool things. And some of the breakthroughs were materials that were able to use nitrogen cooling, which is obviously at a, you know, higher temperature than, let's say, liquid helium, stuff like that. So there was some changes there, but still you need to get near 0 Kelvin.
Okay, so for analogy here, and just, you know, for the purposes of building the intuition of everyone, so you can kind of imagine, right, as that you cool down this medium, this particular thing, this conductor, right, you are reducing the movement of the actual atoms, right? Because temperature is a measure of the kinetic energy of the atoms, right? They're moving around, and you're reducing the movement. It's kind of like you're reducing the wind in a tunnel, right? And then you can kind of sail through more smoothly as opposed to having headwinds. Is that
Exactly.
analogy kind of correct?
Yeah, it's actually very correct, because at lower temperatures, what's happening is you have less entropy, you have less chaos happening. So that means you have also less phonon vibration, which is basically heat carriers. So of course, one of the ways we know we lose we get resistance in materials that are conductive is actually basically the vibration of these heat carriers. So that's why we lose energy as heat, right? When there's friction. And with superconductors, what you more or less want is you want there to be a medium that has zero measured resistance. It will never really be zero for obvious factors, right? But it needs to be low enough that the so-called zero forces are greater than the other forces, right? I think we have to kind of get that in check. The term zero doesn't really mean zero, right? There will always be some kind of resistance due to measurement issues, right? So of course it will never actually measure zero, right? But it will measure it zero enough that we can make something meaningful about that measurement. So the lower the temperature, hey, less vibrations happening on the lattice, the structure of the atoms going on. So which obviously causes, think of it this way, right? If you have if you have a road, right, and all the cars are stationary, and you're trying to drive through those cars and avoid hitting them, it's easier than if the cars are moving, right? It's more or less that simple. So that's where the low temperature comes in. Then the high pressure, you need high pressure again to confine the atoms into a smaller sort of crystal lattice that again is closer. So the path length between where the electrons can travel is more or less smaller. So you're trying
Everyone
to
has heard of a pressure cooker before, right? So the idea of the pressure cooker, okay, so you increase the temperature and we increase this traffic, right? We increase the wind, we increase the movement, the kinetic energy of this stuff, right? And then this water wants to escape and become a gas and become even more chaotic, right? But with a pressure cooker, right, by constraining the water, it can remain a liquid at higher temperatures. That's what a pressure cooker does, right? So in a similar pattern here, you're kind of holding things together, literally in a kind of a, I don't know what literally means here, but the mechanical analogy I think holds, but go ahead.
Yep, exactly. So now we're getting into how did they do it? How is LK 99 made into a superconductor, and how do they measure it, right? How do they prove that it's a superconductor? Well, to be a superconductor, there are some basic sort of definitions that you have to meet that have been defined, right? One of them is you have to have a certain voltage, right? When you put a current to it, you get voltage, right? There's a certain voltage based on a certain amount of current that you get out. It's about 0.1 microvolts per centimeter to about 1 microvolts per centimeter. So it's within that range. That's one of the sort of classifications met. Another one, obviously, is when you do apply current to a superconductor, right? You should get zero resistance, measure resistance. Now, of course, what the great thing about this LK99, so from 300 Kelvin to about 400 Kelvin, they have maintained zero resistance, meaning according to their measurement efforts, this actually is a superconductor, right? I've seen the videos online whereby they're showing some floating LK99 on some, magnetic sort of base, and people are saying, well, this is just a diamagnetic or ferromagnetic, right? These are different properties that can affect that sort of levitation, but that is really not that relevant, right? Whether it levitates or not at room temperature, sure, that is one way that we've measured superconductivity, but what they're also claiming is that this is superconductive under specific lattice structures on the three-dimensional part of this material. So it's not going to be superconductive at all locations. It's only on certain axes, which of course is so incredible, because what you do is then you create the largest structures based on the correct orientation. Now, of course, that's going to be more difficult, more expensive, etc. But this definitely is a great change in technology, right? We've had a lot of stuff happening with software engineering and the computers. Basically, every year, every couple of years, yeah, go ahead.
Yes, sir. Yes, sir. Yes, sir. I'm sorry. Go ahead. There was a phone call thing.
All right. So every couple of years, and people call it the Moore's effect, right? Whereby every couple of years we've managed to kind of reduce the size of the semiconductor chips in our computers by half each time, right? Which of course means we're getting faster because we can put more of them in, and we can get higher speed from the CPUs, the GPUs, etc. But that was actually us just using basic materials physics that we have. This is the first time in a while that we actually, if this is correct, right? And people have actually made this material and replicated it, tested it. Some people have got the same results, etc. But once it's properly verified and a lot of research done into this kind of materials, because it's not just this material, right? This is just a type of material. It's a type of lattice structure where there's lead ions and then also copper ions in a specific structural arrangement. And it's also deposited using something called thermal vapor deposition. So what that is whereby a lot of heat is applied, obviously, by this very expensive semiconducting machine. It basically more or less vaporizes the material. Then it deposits it as into a thin film, right? Nanotechnology, right? Or you can actually deposit into like big chunks too, of course. But that's where the tests come from, the nano based technologies. It's not Chinese, it's South Korean, I believe, the manufacturers of this technology. Yeah, it's Ji Hon Kim. Yeah, these are South Koreans, not Chinese. Sube Lee, etc.
Okay, so let me take a step back here just to kind of just lay out some more context, and then we can continue whichever direction, whichever way the wind blows. Ladies and gentlemen, go ahead and click that like button as you come in. Future being material. Okay, material science, right? Where our dreams are going to be fulfilled regarding free energy and endless material replication in terms of ordering steaks and replication machines from Star Trek and stuff like that, flying cars and holograms, holodeck, right? Those kinds of things, creating all kinds of experiences, relatively low amounts of energy in order to kind of create these experiences, quantum computing even, and all these other kinds of things. In all these areas that I described, we've not seen a lot of progress since we started dreaming and creating sci-fi movies about them, right? Or I actually, it's kind of interesting because both the Greeks and I think both Jerusalem and Athens have this kind of AI or automaton kind of robot type structures in their in their mythology, by the way. I think Jason and the Agonistos or something like that was one of those. But anyways, ever since we started to dream about these things, we haven't made a lot of progress towards it. I think that recently we've made progress in the area of biology. Let's say biochemicals. We've been making a lot of progress in that regard. But when it comes to energy production, when it comes to transportation, for example, planes, for example, are getting slower rather than faster. Okay, so we went up to the Concorde at some point, kind of a supersonic flight and all that kind of stuff, but it wasn't cost effective. Well, why wasn't it cost effective? Because somehow we have not made a lot of technological improvements in energy with regards to energy and stuff like that, right? So, but is there a are there any geopolitical consequences to this? Because with something like this, are there any kind of material or mining aspects, or it's just regular copper and something else that can be gotten anywhere, or is it the case that maybe this might lead to people realizing that there's a particular, anyways, are there any kind of material mining consequences to this particular discovery?
Yeah, so great question. So yeah, so this particular material is more or less lead, is copper, lead, sulfides, and other sort of lead-based materials, lead, copper, and oxygen or sulfur. So these are very sort of relatively abundant materials. But here's the thing, right? Even copper is not copper is actually gotten from Africa, a lot of it, right? Countries like Zambia, for example, Zimbabwe, heavy copper mining positions, etc. The lead, I'm not too sure which countries have lead, to be honest, but it's irrelevant whether this material, it doesn't need, this, let's say, our typical semiconducting stuff like germanium, tellurium, and all that kind of stuff. This is just a sort of an example of what can be made with this specific material. But if we actually look into, let's say, materials physics, semiconductors tend to do better than actual these metals in the normal place of the periodic table. Meaning, once more research is done, semiconductors can actually be more tuned, electronically tuned, to actually perform better sort of better characteristics. So I think all this does is just shows that it's possible. But the semiconductors is where you're going to be actually able to control the electrical configuration, because you can directly control the Fermi level, right? The energy level between the conducting phase and the non-conductive phase. Tune it exactly to what you need.
Now,
so one of the go ahead.
Now, I was gonna ask you a broader question on the material science front. Besides this particular development, right? Is there any other space where things are happening in material science that are exciting? I think everybody at some point kind of went through the kind of carbon nanotubes, right? Okay, carbon fiber phase.
Yeah, I used carbon nanotubes and graphene. That was actually the breakthrough of my experiments. I was actually carbon nanotubes, and so they actually helped a lot in my experimentation. But
yeah, so energy transmission, material science do have a kind of a nexus point, obviously an important kind of thing there. But I was going to just ask you to perhaps maybe talk a little bit about the advancements on the material science end of things, right? Like the carbon nanotubes, and perhaps how they may also aid in the energy and whatnot.
Yeah, so right now, the hot materials right now in materials physics is stuff like, there's something called perovskites, right? Perovskite is a type of, again, lead iodide type of system with some infiltration of other impurities. We call it doping, right? So you add a little bit of an impurity in there, like some semiconductor, like tellurium or something else, in the lead iodide structure, and this allows it to have the properties that you desire. Like, it's tuning the electronic configuration. So one thing that this material is great for is it's relatively cheap to make. I could fabricate it at only 100 degrees for, I believe it was just 10 minutes, no, even 6 minutes of 6 minutes at 100 degrees, right? Celsius. You can actually anneal. Annealing is the process of basically making the atoms come together and join together into an actual crystal structure. So you can anneal perovskites, right? Lead iodide perovskites at only 100 degrees for like 10 minutes, right? That is a great improvement from the way that we fabricate solar panels using silicon, over thousands of degrees for a long time before you can create the crystalline structure, right? For it to be effective as a solar as a solar material. Also, materials like this lead perovskites, what they can do is very, very high efficiencies recorded. I think the official is like 25% efficiency. That's really high, actually. Efficiency, relatively cheap, relatively not heavy. You can make it into nano thin films, so you no longer have to have large crystals like the silicon ones. You can just make them like 10 nanometers. Okay, I'm exaggerating. Let's say 60 nanometers, right? Thin, meaning materials cost, you're saving so much materials. You can print it onto.
Let's pause here for a
Yeah.
second here now, and let's talk about some of the, perhaps in any of the areas that you just described, right? The kind of the broad sweep that you made. Where are the areas where there have been some exploitation already? In other words, are people already working towards that particular area, perhaps even making a product, making some economic kind of, creating some efficiency out there in the market that that people are willing to pay for, right? And then
Yeah.
areas where that are still kind of more open, if you will, open-ended. Go ahead.
Okay, so areas where there's already like actual let's say commercial investments is have you seen the OLED screens? These days you can have phones that can basically floppy phones
Mhm.
where you can bend them and open them up. I don't know if you've seen those phones.
Yeah.
They're already in the market. You can buy them already. That's the first phase. The second phase actually is to create tablets, or that's more or less just a plastic sheet, because this is the field of plastic electronics. Plastic sheets whereby you can put it more or less like a gazette. You open it up, you've got your screens, you've got your writing material. It's just more or less like a piece of paper that is very thin, right? It's thin film technology. And that's already in the market, actually. So that stuff has already been exploited. You have solar panels that are flexible as well. It's a thin film materials, again, as thin as, let's say, 1 millimeter or even smaller, that can produce energy for free, etc. So those things are already in the market, as an example. When it comes also to superconducting materials, they do use them, but this is more like space travels and stuff like that, whereby, let's say if the solar energy is too far away, if you're going to a faraway mission, you use thermoelectric materials with superconducting arrangements to allow for, obviously, more energy exploitation. So that's some of the areas. Also for nuclear physics, they're using these new super materials to actually basically make sure that there's less energy loss in the nuclear system. Third generation nuclear technology is not the same as the first or second generation. It's a lot more efficient. And also there's quantum computing, right? These materials, again, these semiconductors are used to make ion-based quantum computers. And of course, for quantum computers, what you want to do, obviously, it's no longer a binary system of 0 or 1. It's a 0, 1, or a quantum state, which is neither. So if you're using, what they're using is ions, right? So positive ions, negative ions, and they're using a charge gate to control basically where these ions are going to be. Either they're going to be in the neutral state or the on or off state, etc. So that stuff is already being made. IBM has supercomputers. Quantum computers, which you can test out. Quantum computing algorithms are already being created. To be honest, if you want to make money in the next 50 years, right, learn quantum programming. I would say you can test it out by joining an IBM machine computer to start testing out your algorithms, because this is the stuff of the future. And even right now, you can still get jobs in it.
Quantum programming or TikTok star. Now, D here is asking, talking about planned obsolescence, which I just want a quick comment on that. I don't know if you have a comment as well, but it's when there becomes a dependency on the velocity of money rather than, in other words, in that value equation where you have the quantity of
Typically gonna be
stuff.
10 years
Pardon me?
for last. It's going to be 10 years. They've sort of capped it at 10 years production. Oh, sorry, lasting for about 10 years. These sort of things.
Yeah, and there's a whole kind of there's a system to the whole economy. Now these things are emergent. Doesn't mean that somebody sat down and planned it, but depending more on the velocity of money, right, rather than, So in the value equation, you have you have the quantity of goods, you have the price of the goods, and then you have the velocity of the money, right? In that m cube whatever v uh
Right,
money
right.
equation. But uh you have to when you heavily depend on, or planned obsolescence is in line with depending heavily on the velocity of money. You want things to be circulating, right? You want purchases to be happening, money to be circulating, as opposed to more depending on maybe the value, in other words. But anyways, I'm just musing out here, ladies and gentlemen, as we're talking about the future being material. Shout out to you guys. We got Zone, the dusty Asian, some kind of Asian. I don't know what kind of Asian. I don't know if he's Taiwanese, Chinese, Vietnamese, if he's Hmong, if he's from Taiwan, if he is Japanese. Anyways, insanity. Now, let's take a step even further back a little bit with regards to the state of theoretical physics, right? And our level of understanding, I believe, of like the periodic table, the atom, um, and electromagnetism in general, and why certain atoms behave. That kind of nexus point between chemistry and physics, right? And also all the way back, what will be your commentary all the way up to the point of like theories of everything, like, or by theories of everything I mean over even something that is just seeking to combine general relativity with quantum mechanics, right? Trying to just combine that kind of gravity space with the small quantum space and unify all these forces, blah blah blah. What is your general sense of the mistakes being made there? Okay, now that's a big question, but
Yeah.
I think you can handle it.
Yeah, I'll see if I can detangle some of the questions you asked. So, the state of theoretical physics right now, unfortunately, it is unfortunate. Millions of dollars, or actually hundreds of millions of dollars, was spent on things such as string theory. Right, string theory is one of those theoretical physics fields, which is actually more math. It's not even physics because it's not based on anything real. Because the difference between physics and math is one can actually be substantiated by experiment, and the other one is it can just be abstract. So what's happened is a lot of money was spent on abstract fields like string theory, which actually led to nothing so far useful in the actual understanding of the universe. Yes, a lot of mathematical useful things have come from it, but that's a very separate argument, right? As a mathematical field, it's great, but as a physics field, it's done nothing to enhance the standard model that we have in physics. So that's part of the issue. It's a lot of money was spent, and of course, you have the sunken cost fallacy going on. Well, just a little bit more money, we're going to have a breakthrough, right? Because and let me just instantiate why string theory sucks, right? It's because it's just a bunch of people trying to figure out the logic of the theory of everything. Okay, they're trying to kind of figure out the abstract nature of reality in a realistic sense that then you can predict certain outcomes from it, and then it's going to help us save so much money from experimentation. Because then if they have that theory of everything, the argument is then the chemistry, the biology, the physics, you can predict and use predictive models to more or less test out every experiment without going to a loss. So let's say experimentations which more or less we would have done just for the sake of it, since they're basic, having a theory of everything will more or less be able to give you ideas. No, this is unlikely to yield what you're looking for, etc. So that's why even the idea was sort of kind of loved by a lot of people. Now, say within that same field, there's also another theoretical physicist who kind of don't like that whole looking for things in an abstract way. They're looking for real stuff that can be connected to the real world as well, and I think they're also kind of lost as well. You need both. You need to be extremely abstract, and you do need to actually go test out things in reality. And I think that marriage of those two sort of mentalities hasn't really happened yet. On
So
one hand, yeah, go ahead.
I think, for example, you could have an actual issue with the model, the standard model as you have it, whereby the standard model of the atom and all that stuff, like with the muons and the gluons and the quarks and the bosons and the right.
Yeah.
all that stuff is happening. But then there's this general relativity world, right? With the curvature of space and galaxies and black holes and all that kind of stuff. And you just see like, okay, there's an issue kind of making these kind of mesh. And in there, you have this guy on the one hand, the first guy you described. It's like, okay, I'm gonna go deep, deep, deep into the abstract realm. Okay, come up with all kinds of crazy, fancy mathematical objects, and they wait to kind of put these two things together, right? And I'm gonna find all kinds of wonderful things in this crazy land of wizardry, right? Such as that being the mathematical kind of advancements that you referred to earlier, right? All kinds of new mathematical tools and insights and whatnot, right? Models and all these kinds of things while you're studying this string theory, which is going to unify everything. Okay. But it's not even possible to experiment upon any of your predictions, even if we had the most, right? In terms of just simple to put things in terms that people are kind of at least grok. We're talking about size here. Okay. You're talking about sizes so small, so much more like we're not just talking about an atom here. Right? An atom is like a whole galaxy compared to the kind of spaces that
they're working on they're working on space on sizes lower than the Planck length, right? Yes. That's like the maximum size of atoms and stuff that we can actually look into. So if you're going to go smaller than that,
let me say something about the Planck length, because it was one of those things that I thought just it's easy to understand, but it was never quite intuitively stated. In other words, I think people understand what a black hole is, right? People understand that a black hole is a concentration of matter / energy, right? Whatever, same thing, right? Such that it curves space and time so much that everything falls in, that kind of a thing. It was like, okay, cool, we get it. Now, the smaller the area you have, right, the less energy that you would need to curve it, right? Like makes sense, right? Okay. So there is a certain amount of energy that you can put into a tiny little space before you create, quote unquote, a black hole, right? It's kind of how I like to think of the Planck length, right? It's like, what is the smallest energy that I can probe? And the reason why small spaces require high energy is because you need high vibrational things in order to probe small cracks, right? You can't use this long, lazy wave to probe, fine details in the bottom of the river. You need some high energy waves, right? Blah, blah, blah. So, but at some point, the energy gets so high in this small area that it becomes, I can't probe beyond that point. I effectively create a black hole, right? And that length is the Planck length. Am I in the ballpark?
Yeah, that's it. Yep.
Okay, but I'm sorry. Go ahead.
Yeah, he has a measured number in it, but the intuition is correct on that point. And also, I wanted to respond to Chukwe's point. Is string theory even falsifiable? Well, yeah, it's falsifiable right now because we can't actually measure a lot of the stuff that it claims. So it is not even a theory. Let me just make that clear. String theory is a name, but it doesn't actually meet the standard to be a scientific theory because there's not enough evidence or from experimentation. So it is actually not a scientific theory. It's actually a hypothesis, but they just call it string theory. That's going to confuse people on that kind of stuff.
Yeah, I mean, it's not sufficiently distinguishable from just mathematics, right? Especially from the point of view of the someone who's not in there playing inside baseball in the physics departments, right? Then it's mathematics, and is mathematics verifiable? No, mathematics is what it is, right? It's a self-consistent system. So
yeah, and actually that's something I want to mention that you just brought that up, right? So one of the issues with string theory is that you create a model, right? You create a standard. The problem is these models are self-consistent, meaning they're true given the parameters that you've created to be true, right? For example, it's the language game stuff going on, right? If a bachelor is an unmarried man, then that statement is true if you call something a bachelor. Now, then you also have to substantiate, well, what is an unmarried man, right? You keep going down that rabbit hole until you reach some linguistic, singularity somewhere. So that's part of the issue with string theory, is that it's a self-consistent model, but the premises, right, the axioms that it creates, that's where we're not too sure if it's right or wrong because we can't even test it out at that level. And what we do know is a lot of the stuff that it predicts on a global scale is actually wrong as well. Some of it is right, and some of it is wrong. And in scientific theory, when too many things are wrong, especially at a fundamental level, is when you kind of, well, you can't state it as a scientific theory. An example is, let's say, right now, the two main, theories in theoretical physics that sort of at the edge of our understanding is the Einsteinian understanding of space-time, right, and gravity, and all that stuff. And also we got quantum physics. In fact, even this this new superconductor, it works because the distortion of the impurities introduced in the lead copper lattice structure actually decreases. So what happens? You introduce some impurities like oxygen doping or sulfides, and it actually reduces the size of the lattice structure, meaning it's more condensed. So what it's doing is it's replacing what would have been created by a high pressure by having this impurity, and it creates quantum wells. So basically, these are quantum structures that can allow, quantum traveling between the electrons and phonons, right? Electron and the phonon is heat carriers, so they can actually quantum tunnel through the material, meaning they're more or less, they're transversing through the material. Yeah, they're teleporting. Right? I don't like using words like that, but they're teleporting through the material. That's one way they actually have so-called zero resistivity, because they're not going through the path length, the regular path length, where there's a lot of obstructions in the material and losing energy that way. So
okay,
yeah.
I thank you very much. And if I recall here, ladies and gentlemen, okay, if I were to take us back to the place where I asked you the question about the kinds of mistakes that are being made in theoretical physics, after we've kind of talked about this superconductivity and whatnot, and we'll get to more and more of that as people continue to click that like button and share the stream. But I want to take if we go now to the theoretical side, in other words, when the people whom do that the string theorists, the people who do the string theory mistake, when they do things right, it could look a different way. In other words, it may be more intuitive, such as, let's say, Isaac Newton's discovery of calculus, which was not very tight, but he had certain leaps there that he was intuiting and sending out there. So, but that kind of thinking today, in other words, if Isaac Newton came out today, and correct me if I'm wrong here, with regards to my observation of one of the mistakes that is being made with regards to the edge of theoretical physics type of understanding, is that if Isaac Newton were to come today with this type of thinking, this kind of intuitive thinking, where there's logical gaps, where the symbols don't really work out, the math is not all that clean, right? People will be like, oh, it's all BS, and they'll just attack the math and attack the whatever and say, oh, all that stuff is blah, 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 blah. So am I correct that there's a lot of non-recognition of leaps of intuition, or sufficiently, in this kind of trying to unify in the quantum gravity race, if you will?
Actually, it's so yeah, 100%. So one of the problems is actually that there is a lack of so let me go back a little bit, right? So you understand Gödel's principle of what was it called again? Incompleteness theorem, right? Right, incompleteness, right? So if you understand incompleteness, so this is why, okay, Leah, let me try to break down all of it, right? And I'll answer all your questions the best I can. In math, forget physics, right? We're talking about math, which is abstract, right? In math, there's a theorem which is more or less true. It's not even just a theory, right? You cannot know you cannot know everything, and also be able to predict that everything into infinity. Meaning, I want to simplify what that actually means, right? You can't go around creating a mathematical model, right? Right now, we in math, the main models that we use is set theory. You create sets, right? Sets are, like a set of plates, that porcelain plates or something like that. That's a set, right? Forks, spoons. These are different sets, right? If you put them together, they also contain in a larger set called utensils, right? So these are just sets on top of sets on top of sets. So one way that we use math, right, theoretical math, is set theory. Another one is group theory. It's a different variation. People claim it's a little bit more deeper and complex, but it's more or less the same sort of logic, underlying principle. So according to Gödel's incompleteness theory, what it says is that, and it doesn't just say it, it's demonstrable, right? You can create a theoretical framework such as set theory or group theory, and everything can be true given the context of what you created it for. but it will not account for everything. There'll be some things which are also true, demonstrably true, using a different theoretical framework, but it would not be accounted for in the other theoretical model, meaning you can't contain infinity. That's more or less what incompleteness is. It means that the way that we do maths, we cannot contain infinity, because when we do
Basically,
math,
okay, let me so all these edifices, all these theoretical edifices, right? These structures of knowledge, right, are like games with rules. Once you create the game set and the rules, these are the pieces. The pieces are going to play these particular parts, and these are the rules with regards to how they move. Let's say, for example, chess, right? That then everything becomes self-consistent, right? And everything makes sense. It's a self-consistent theory, but there is nothing in there that tells you about why the rules necessarily are you cannot derive everything about the rules from. In other words, there's some point of arbitrariness with regards to the border around which you've tried to contain this infinity, to kind of switch to your kind of metaphor, right? And to me, it's
yeah,
kind
I
of
mean,
intuitively kind of clear that, of course,
yeah.
yes, there is no way to be looking in and out at the same time.
I
Go
mean,
ahead.
try to even describe a three-dimensional field like a room. The most you can do is say, oh, there's three dimensions, right? X, Y, Z, right? Up, down, the other side, and you can say that it has this shape and materials that fit this cuboid. You can describe it to so much, but you won't be able to describe the actual infinitesimal spaces, which can also create infinitesimal, let's say, dimensions within it. And the moment you go and create a specification, right, an identity, you say this is this, you're already saying that it's not something else, even though it could be something else, right? You're choosing a very specific descriptive model, and that obviously limits the actual absolute truth in it.
Okay, so let
And
me
yes,
ask you a question now. In the space of people whom have maybe more intuitive theoretical models that will unify gravity and quantum mechanics, right? That would unify the physics of the large, which is like the general relativity, gravity type stuff, where gravity rules, right? Gravity will rule in large stuff because you're talking about massive things, bending space time, and all that kind of stuff. And then there are the rules that apply in the very small areas, right?
yeah.
Yeah.
So hang on, before you confuse everyone. Yeah. So the incompleteness states that things can be true given the context, right, of space, size, and other contexts. So yes, locally, for example, Newtonian physics, it's very true, right? If you throw a ball, given the wind direction and given the force on that wind, given the
Mhm.
weight of that ball, given the force that you threw the ball in, you can predict the trajectory and also where the ball's going to land, right? And that's true at a localized level, right? Us level abstraction, things that are our size or a little bit smaller or a little bit bigger. But you take that math, right, Newtonian physics, into space, right, the larger cosmic stuff like movements of planets, it breaks down, and that's why you need Einstein's theory to kind of expand the understanding, right? Einstein's model becomes more true in space, right? Large objects, space time, and all that stuff, right? That kind of accounts now for the extra observations that you have, and the slight deviances where, let's say, Newtonian physics would project certain lunar phases. It's a little bit off because of that. So meaning we as human beings are unable to actually understand everything in its entirety because our models break down. The moment you define one thing one way, it leads to inaccuracies.
Mhm. So within the space of people trying to kind of codify this, what is called what are called theories of everything, or to put it more neatly, just trying to at least unify general relativity with quantum mechanics, right? Trying to unify the big with the small type stuff. Is there any people? Do you like the quantum gravity people? Do you like Eric Weinstein's crazy crazy ideas? Do you like the geometric type things that would try to unify, or do you have your own kind of 0 point energy type? Where 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 do your sentiments lie in this space with
Yeah.
regards to everything? And
Right.
then we'll get
So
back to this. Anyways, go ahead.
yeah. So before we answer that, we have to obviously state the problem, right? The problem is quantum quantum stuff doesn't agree with global stuff like Einstein's theory of gravity, right? There's a point whereby quantum mechanics and gravity understanding breaks down. One can't predict the other in a uniform way, right? And quantum physics is true in quantum scale, very true. And however, Einsteinian general relativity in connection to large objects like black holes is also true. The problem
So
is when
hold
you
on a
try
second.
to,
I like to do these crazy visual things, and I like to, like, for example, previously when we were talking about the incompleteness theory, I talked about games. I was like, hey, within the game, it's everything itself is consistent. The horses move this way, blah blah blah, all that kind of stuff makes sense, But you have to understand that you're within a game. So the issue here that could be visualized with regards to the big versus the small is like you have this kind of chessboard, and everyone has visualized before, hey, here's a planet, and here's the dent that it puts in space-time, right? Space-time curvature, that type of stuff. So you have this kind of game, right, going on, and you have the rules and the pieces. And then you start zooming in, and then all of a sudden a different chessboard appears, right? That controls the movement of these electrons
exactly,
and the uncertainty and stuff like that.
right,
So it's like all of a sudden, when you zoom out, you have one chessboard that you're looking at, and here the way the rules work, the energy will curve space-time in this way, causing X, Y, and Z to happen, and all that kind of stuff. And then you keep zooming in, and boom, all of a sudden the chessboard changes to some weird, more probabilistic BS
right.
stuff going on down there. But anyways, go ahead.
Yeah, that's exactly it, right? And another analogy there is like, let's say water, right? Water is, I believe it's H2O, right? One hydrogen, one hydrogen, one hydrogen next to two oxygens. No, it's H2. No, two hydrogens next to one oxygen. Anyways, water is H2O, right? Now, independently, right, as the atom, it has a different property than when many of them join together. Now, of course, you have vapor pressure and stuff that's going on. And then when enough of them join together, you have them joining into a droplet, meaning the physics changes based on, let's say, the size, the pressure, and all that stuff. So the difference with quantum physics, and
H2O molecule, you would not recognize a single H2O molecule. It has nothing to do with what you call water.
Exactly. So there's a phase change that occurs, that now we know why it occurs, right, using quantum physics, but that's just an analogy to say that we don't know why the quantum rules change at very large objects. And again, even this very large object, these are very large objects that we have identified, right? They are larger objects like galaxies and all of that kind of stuff, which we still haven't fully, let's say, analyzed because we don't have the same precision elements to them. So my abstraction here is kind of simple. You asked me a question: which ideas do I think are close to kind of filling in the gap, and some quantum gravity stuff? And do I have my own ones? I think all the ideas are kind of basic, and one of them is just quantum gravity can actually happen using a field at this Planck length. Is like a field, like a matrix, whereby you actually have quantum stuff happening, and when it get big enough, what happens is the quantum physics stops operating the normal way, right? It's now becomes let's say observed matter, because now it's interacting with other things. So think of it this way: like humans or any material, we're mostly empty space. Of course, when the only reason why when we touch things, there's a we don't fall through things is because of the electromagnetic repulsion that occurs between the electrons, right, and the atoms, depending on the charge attractions going on. So one of the ideas is that at the very small quantum scale, there's not enough things to interfere with each other. So what happens is you have the quantum tunneling and all the stuff that happens there. But on a larger scale, what happens is, because of now the interaction from the larger objects, there's now a force field that disallows for the quantum effect to take place, right? I'll say I agree generally with that kind of thinking, but my reasoning is going a little bit different. I actually think that there is no difference, right? I think that it's, as you said, like, it's just a change of perspective going on from the small to the large, and this is not even the limits of scale. I believe we're just analyzing the scale that we have the precision to analyze. I think it's circular. It goes into an infinite loop of these concepts on various different scales and sizes.
Okay, let's take a sharp left right now. What's going on with your brothers in the Sahel out there shooting? Police and thief in a shootout. what I'm saying?
Yeah. So unfortunately, what's going on? Unfortunately, what's going on in the Sahel right now is we have at least three countries. We got Burkina Faso with a young leader over there. Shout out to them. Mali as well, and Niger. Now, what happened recently in the Sahel is Niger decided to have a coup. It was a military coup, and it's supported by the populace. Right, 85% of the people say, however that number is derived, say that they support the coup, and the coup removed an Arab leader, actually, which is interesting, from power, who had been selling off, and there's evidence of this, right? Selling off the resources in the Sahel, such as uranium, oil, and gold, to the French at very minimal costs, right? There was no drop back. Niger is like the fifth poorest country in the world, for example, with so much resources, right? In, for example, France, more than a third of the energy is powered by uranium from Niger directly. And that's just an example of the total energy consumption. Now, one of the issues here with the Sahel countries is this. Most African countries that were ruled by Britain or Germany, those guys just left for the most part. Yeah, sure, they have the companies like Shell in Nigeria doing their thing, but it's not very parasitic like the French. The French didn't leave Africa. They still have colonies in Mayotte in Africa that's directly ruled by them, which is etc. And also, the French instantiated a system called the CFA, the French, the Central African franc, and also the West African franc. These are basically currencies that are linked, that used to be linked to the French currency before they joined the European Union. Now it's linked to the European Union. And guess what? One of the conditions for, let's say, these countries to use these systems, which they adopted, again, through elite members, right? These elite rulers who did these deals that benefit them and not the people, chose these deals. And one of the conditions is that at least half of the Federal Reserve currencies, right, of these countries would actually remain in French banks, meaning they're actually tied to economically with France. The money or the Federal Reserve is literally French banks, meaning they can't even escape the rulership. Because someone would ask, well, why don't they just leave? No, this leader over here invited French troops, about 3,000 of them. The economic system is linked, tied to a point whereby you can't just leave. You lose half of your reserve currency, and you can't function without that money, etc. So it's that was a main reason.
Move? What will be your move? Okay, so you have this small, poor country, right? And you don't seem to have many degrees of freedom here with regards to what you can do freely and whom you can ally with and whom you choose to be a puppet to or whatever. But what will be your move in this particular case? If go ahead.
Okay. Great question. So since I'm a small country, I have to think of this logically. Okay, what do small countries do? They leverage what they have. In this case, you have uranium, you have some gold, you have some oil, right? You know who one of the largest oil producers in the world, and you know who is aligned with the country that you don't want. What I'll do here is I'll leverage my resources to a country that will give me direct infrastructural development for access to its resources, right? So in this case, if I was in Niger, I would do probably what Niger is doing, but at a slightly higher level. Instead of just bringing in Russia, I would bring in the full BRICS. I'll bring in the Chinese as well for infrastructure development, and I'll make it make sense for them over there. So right now,
people who say, "Hey, you're just going from the frying pan to the fire. You're just going replacing one colonizer for another colonizer, or blah blah blah." What would you say to such pushback?
Yeah. So what I'll say is this, right? The deals that I'll make sure that these deals are not parasitic or transtemporally limiting. Meaning there will be deals that are actually based on business. Business.
Okay. Premise one, deals are inevitable. Premise two, you're gonna try to make deals that make sense. Okay, that's not even really a premise, not a logical kind of premise thing. But deals are inevitable is really what is that are deals inevitable?
Yeah, deals are inevitable, right?
And you don't really have much to offer. We mentioned the conditions. You're a small country and you have resources. That's what you've got. That's all you've got.
And as a small country, you have a lot to gain, because what that means is, for example, right, the small monetary, let's say, money coming in is going to do way more for you than it would for a large country. Your population's education, I'll give you certain deals I would make, right? I wouldn't just sell the oil to Russia and and be like, oh, here's your oil. You can still control your stream there and give it to the Europeans, etc. So you still remain power. I'll say, hey, Russia, hey, come in, build a refinery here with us. You will actually get a big piece of that refinery. But what happens is, right, at least 50% of the workers, and I'm talking about top to bottom, right, 50% at each level is going to be my own population. So in that case, actually what you're doing is you're more or less buying technology, stuff like that, right? There are deals which actually the other side would accept because in a temporal framework, it benefits them even more than you. But in a trans-temporal framework, it benefits you more than them. And that's part of the issue with some of the deals that was done by the older generation, right? They did deals that benefited them directly in real time, but misappropriated the temporal aspect. So I would make sure that I do deals that make sense across time.
Okay, so this misunderstanding of the temporal aspect, this kind of short-sightedness, myopic, generally speaking, people will always have this kind of complaint about governments, because of the nature of incentives writ large, right? However, it does seem to be the case that whole generation, all through the geography as well, all through Africa, right, there seems to be this misunderstanding of the transtemporal, right? Now, is that true? And is there any hope in that case? Now, sure, if you sneak in there, take over, pop a few bullets in the air, and then you can be transtemporal. But writ large across the area there, with ECOWAS, with the dusty Nigerians, can they just stop scamming for a second and think in a transtemporal manner, or no?
Yeah, so I would say, according to, actually, we've done a video on this, right? Being in time, and we basically broke down a theory that Black/African descended individuals, they don't have a transtemporal framework for reasoning, right? The modus operandi is actually real time. We call it SE. Africans are good at I see shit, I do shit. They're not good at, let's say, projecting into time, breaking things into temporal inferences, and then seeing things as they sort of emerge across time. They can't do that. We already understand why. It's because of the way that the continent was structured, abundance and readiness, right? You don't have to travel.
A point about that kind of communication with regards to absolutes. It's not about they can't do that. Okay, it's it's almost like the water
energy.
could flow over there, but it's like energetically, it's preferable to flow this other way, right? Due to a whole set of conditions, right?
Right, but it's like electricity, right? Electricity can go through any. Imagine you've got three materials, right? You've got copper, you've got gold. I think gold is higher conductivity. It doesn't really matter. You've got copper. Let's say you have lead, and then you have a piece of rubber. Electricity can't go through rubber, right? Electricity can't go through lead, and electricity can't go through copper. But given those three options, 100% of the time, most electricity will go through the copper, some of it will go through the lead, and almost none will go through the rubber. So, this kind of breaks down the whole temporality with African mentality. Is most Africans will not think across time, some will, and a very small amount of Africans will think across time, which obviously leads to the issues with having leaders who are not selected for these properties. Leaders are selected through tribal affiliations, and of course, you're generally going to get low people.
So basically, the tribal logic is therefore the area that transtemporal thinking is supposed to happen. In other words, through the traditions of the tribe, through the politicking of tribe by tribe, kind of inter-tribe social Darwinism, right? Inter-tribe competition is the way in which this transtemporal kind of thinking is supposed to happen, as opposed to a system / with leaders and institutions, by the way. Because again, we're talking about, we move away from the abstract a little bit and come to real time. We're talking about what is the difference, right? The difference is, or what is the opposite? The opposite is institutions that have a transtemporal point of view that actually do work. They have a residence, they have a reason for being, they have a long-term view, and so on and so forth. Institutions within certain types of countries like work. I don't know. You pick your country, your favorite one. I don't know. It could be Sweden, it could be United States. I think, for example, the justice, the justice system. The judiciary, in the United States is pretty good, right? Compared to, you want to be tried in Mexico or you want to be tried in the United States. I think most people I think the choice is clear, right? So
The
that is the
UK,
difference.
yeah,
You might take the UK or Scandinavia over
yeah, even
United States.
better,
I'll take
right?
Scandinavia. It's like,
Yeah.
I'll go over there, right? So there are better places that have institutions that have this long-term view, blah blah blah, as opposed to it being kind of like with the tribal logic. Or the
Mhm.
other way to look at this kind of thing from a systemic point of view is that this inevitably is a situation whereby there needs to be quote unquote strongman dictatorship, right? If only, as you mentioned, that if they're into I see stuff, I do stuff, as you say, as opposed to transtemporal thinking, then therefore
Well, so let
the
me
only
give an
system that
example,
works is,
right?
well, go ahead.
Yeah, let me give an example. So some Africans or black adjacent people will come, and this is not just African problem. This is an indigenous community problem, right? Whatever we dub as indigenous 400 years ago, right? All those communities. The the naysayers, right? I'm going to dislodge some of the naysayers, right? Right now, when we brought in the LK99, this new superconductor, we talked about the gaps in materials physics, right? And the things that are going to be utilized as patents for the next gen technology, right? That's about to happen just in the next 50 or so years, right? This is not so difficult area of research. I've worked in it. The logic is not that extreme and it's not that difficult in general. You just have to have basic intuition and logic, right? And even the machines used to it, yeah, some of them are very high tech, obviously, like you know, and there is some, let's say, buying in problems. For example, there's only one company that manufactures the semiconducting making machines that Samsung, Taiwan semiconducting companies use. Sure. That is one issue there. However, in general, the stuff that's used in research, you can buy it. Like one machine for this thermal deposition costs like $500,000. Africans can't afford those. Scanning electron microscopy to see in the nano shaped sizes cost maybe $1 million. Africans can't afford that. To have a high end lab for materials physics, you don't need more than $5 million. Africans don't have that money, Ike. So the point that they're not investing in stuff like this, which is cutting edge, whereby they can get their patents in hand, they're still focusing on being slow. They're reactive, right? So I'm just saying that for the naysayers, it is true that certain indigenous communities are more reactive rather than proactive.
True indeed. And then perhaps what you didn't get a chance to say was it is based on an evolutionary notion, right? Theory that says basically if you evolved in a plane whereby the temperature or weather conditions do not fluctuate or undulate throughout the year very much, where there's either fruit or animals to eat year round, right?
Yeah,
Whether
you
you're
don't need to think
somewhere
about
in the south of Italy or you are in the African kind of area, right? The Sahel, whatever, right?
Yeah.
So you don't have to think or plan too much. You're in the moment. You jump out the tree, you grab the stuff, you do the things, right? But if
Yeah.
you are in some crazy Arctic tundra type frozen hellhole, okay, crazy
Yeah. So
metaphors being mixed
one
there.
second,
But
I
go
want to
ahead.
respond to Mike's V's point. So he says it's not that they don't, the technology export controls. Yeah, okay. So there are technology export controls, as I mentioned, right? The one company in Netherlands and Germany that manufactures all the machines that basically make semiconductors. You cannot buy those machines. America won't let them sell to anyone else, apart from a few companies like Taiwan Semiconducting, Samsung, and a few other companies that are in countries that are directly aligned to America. That is actually accurate, 100%. However, that's at the highest level of semiconductor commercial scale stuff. We can still acquire these normalized research level machines, and the issue is we don't do that. So again, yeah, you are right. At the highest level, that's correct, but we don't have to be at the highest level to do research. And once we do the research, we can now start kind of creating the industrial outputs of making our own machines. And I think that's where I'm saying Mike V is we're not really thinking transtemporally about this. I'm not seeing any feasible solutions for this. We have the money. This is just a few $1 million, and we're not doing it. Yeah, go ahead.
No, very well put. And we can linger in this area and hop to the left here, back to that kind of a political question with regards to the. Then I would ask in Niger there, okay, post-colonial French rule, right? um, is it over? Does it matter? Again, given the premises that we've laid out regarding the
So
inevitability of deals and this and that. Uh, People say there are no permanent friends or enemies. There's only permanent interests and such and such. So this notion of quote unquote colonial and all that kind of stuff, I think a lot of it is kind of just an obstacle to actual realpolitik, an obstacle to looking at the board clearly, right? Right. You call it a banana if you want to. It's a question of what are they offering and what are they not offering. Oh, but those guys are colonial and these other ones are like, well, what the fuck, Anyways, go ahead. Post-colonial French rule, Niger. Is that over? Or these dusty
no,
Africans gonna remain under the boot forever?
it's not over at all, right? This is like a first step. All they've done so far, they invited Wagner Group. Now, let me give the context here because you won't see this analysis anywhere, and I can guarantee that. So why, someone could ask, right? What's Niger's military size, right? Let's use the logic here first, right? French troops, 3,000 people, right? Niger military personnel, right? You can see it's going to be more than that 3,000 personnel. I'm sure of it. So far, I studied 3,000 personnel, right? Even if you look at the technological difference between the French and Nigerian army, why would Niger not be able to kick out France by itself? Why would they need to have Russia, aka Wagner Group? It's because of geopolitics. What happened is France was invited to curb the Islamic terrorism happening in the Sahel, formerly by the president, right? The Arab president, right? So what that means is if Niger was to actually directly combat French troops, that would cause an international crisis whereby France actually has, according to United Nations agreements, right, on wars and declaration of wars, have a right to invade Niger, right? Because that piece of land that the French are in, that is actually French land. And so they cannot encroach on that according to the agreements. So that's why Wagner Group, which is actually a mercenary group, which is not directly linked to Russia, right? That's what they claim, is needed because they are, hey, guess what? It's only Wagner Group that's at hand. France would have to invade Wagner, right? And Wagner is not a country or state. So that is really what was going on with it. And to answer your question, no, this is only the first step of freedom of these French cucked African countries. First, you do get rid of the French military interest in your region. Next, you have to now dislodge the French economic interest. A lot of stuff comes from the French, right? The chickens, foods. The economic market is so heavily intertwined with France that guess what? They're going to lose out so much. The next and last best thing is also to do with the foreign exchange reserve. All their money, yeah, all of it, right? Logically, at least half, but I think all of it, right? All the money is actually in France, meaning they can't just leave France because France will say, hey, we're not giving your money back. You did this. It doesn't really matter. The point is France can take their money, refuse to give it back. So, and if you have no money, your country can't actually function. You can't buy any industrial equipment. You're going to be depending on aid, etc. So no, unfortunately, these countries are not free from France. Logically speaking, they are very in bed with France. What's happened perhaps is this will make France reconsider the parasitic relationship if it wants to maintain, let's say, supremacy over the resources that it already has so far, because now there is a contender, Russia.
Indeed, a contender, and then also, by the way, independently through different geopolitical paths, we ended up with the currency question, right? It was the first time we came up, oh, it's going to be the currency. And then we came up with the currency again. And it is well understood, yes, that currency issue is a big deal. We understand that the dollar is a weapon. United States is slapping Russia around with the dollar, right? Because of the deep liquidity of the dollar, it is the reserve currency, so on and so forth. The euro dollar system and all that good stuff, which you like being all Dunning-Kruger about. But shout out to you.
Hey.
So
now go ahead.
Yeah. Now, if we look within the context of, let's say, growth, right? You look at Nigeria, for example, huge population and very young population. Okay, so it has that aspect. It has a demographic aspect of growth kind of sewn up, because growth comes from, you know, technological growth, technological inventions, or population and or debt growth, right? So yeah, a lot of things are going to happen fairly quickly here. We're talking about within the next 20 years, right? When these, you know, average, I think like the average age in Nigeria is like 18 or something crazy like that, right? Compared to the rest of the world, which we know the numbers of, right? Um, so a lot of the changes that we're talking about with regards to the size of the market and such, insofar as it has to do with the demographic aspect, is going to happen fairly quickly, right? It's not going to be like, next 100 years or something. It's like, no, okay, that aspect is going to happen. Now, there's the other aspect, which is the technological aspect, okay, which I will then take us to the energy front, because Nigeria famously known for its freaking lack of electricity. Those dusty apes over there, right? With their generators, right? That's why
Yeah.
they get personal generators and hoard billions of dollars in Dubai and don't freaking just build a power plant. Shout out to Caesar talking about Nigeria being the only member of OPEC not having a freaking refinery. Or shout out to Dangote, I know, you know, whatever. But on the energy front, right? Because okay, we're saying, okay, cool, you have the population thing down there, but you're going to need energy, especially if there's going to be, you know, this kind of technological kind of growth here, because growth is needed. Because growth also provides opportunity, by the way, because that's what we're talking about, ladies and gentlemen. We're talking about the future. Okay, we're talking about the future. We started out talking about superconductivity and all the benefits that could come from there, whether it be in maglev technology or in quantum computing, you know, reducing the waste of energy, you know, basically increasing the efficiency of energy transmission and all that kind of stuff, electricity, blah, blah, blah. So opportunities were for growth. And the energy question, why the hell can't Nigeria have electricity, Kaiser? Is it low
Yeah.
IQ? Is it
Yeah. Is okay. Do you want to get the TI first, and then I'll give
transtemporal,
you.
lack of transtemporal thinking, low IQ, rather dance and spray money at a party?
Yeah.
Go ahead.
So yeah, all of this is true, right? So we'll start with the first one, right? Transtemporal reasoning. Nigeria doesn't understand that it has to create an actual. Okay, so let's give the problem, right? A reason Nigeria produces electricity, actually sells electricity to Niger, and one of the sanctions for Niger having a coup from Nigeria is, well, we won't, sell you electricity, right? Because Nigeria doesn't have electricity, even much less Nigeria. Now, Nigeria produces electricity. The problem is distribution of it. Nigeria has old infrastructure systems for electric distribution, and Nigerians don't like paying taxes. So, when you increase, for example, Kenya, right? Kenya Power recently has increased how much it costs for tokens, right? The kilowatt hours that we get charged for, because they've basically increased the infrastructure development. Nigerians don't want to pay for electricity. It's one of the cheapest electricity in the whole world. Everything is subsidized in Nigeria. So that's one reason. Another reason is obviously lack of transtemporal reasoning. Nigerians don't want to look into the future. They're looking at now. I don't want to pay extra money. I'd rather go and get electricity for 3-5 hours a day, and the rest of the day I'll turn on this expensive, greasy, noisy generator, because you get used to it. Why do you think Nigerians are loud? Because they're used to talking over generators.
All that air damage from freaking generators. I grew up, I grew up with a freaking loud at night. It's like, brrrr.
Yeah.
Anyway, and it used to be loud back then. Way louder.
They were really bad generators, right? When you're growing up, right? Because hey, what are you talking about? No. Anyways, so
it's being subsidized with fists full of petrodollars, in terms of that's what they do. They distribute to their friends certain barrels of oil a day, and also they also do some subsidizing of certain things in the country, but it's all generally inefficient.
Yep, exactly. And another reason why Nigeria's electricity doesn't work is so apart from the distribution problem, it's also the interest in ministers who own generator and oil distribution companies, right? So this is a bottom level oil distribution companies and generator companies.
Sharp turn back to the future in the energy space. Okay, so we forget the corruption, and we understand that yes, we're going to need to be burning fossil fuels for a while. At least that's my position, and and that's a good thing. That's not the problem. Perhaps why are we not using more nuclear is the problem. Is a question of mine, for example, right? What do you think about nuclear, Kaizo? Right? I'm saying nuclear. I'm saying, look, we're crazy. We have some kind of crazy traumatic mothers against drunk driving thing regarding some accidents that happened over, I don't know, 50 years ago, like
Well,
in a
hang on.
whole freaking different planet. Oh my God,
That,
Chernobyl and this other thing. Oh my
right,
God,
right,
that happened. Like, even if it's
right. But
demonstrated that it's not even possible right now. But anyways, go ahead.
right, like that's the reason why the West doesn't want to use nuclear. The reason why Africa doesn't want to use nuclear is a separate problem, right? The reason why Africa doesn't want to use nuclear is because of the fact that the nuclear industry is so heavily regulated. To get
Yes,
approved to build nuclear stations is very difficult. It's not impossible.
That is part of the West.
Oh, right, of course, yes, you're correct.
I mean,
Yes.
it is the
So
West.
they're the ones.
On
Yes.
it. If the West was so, they're being mothers against drunk driving Karens about it domestically, and obviously they're like cock blocking everybody else from doing it.
Yeah.
Right.
Yes.
So, but it is insane. You can't be screaming about this stuff. Being the hydrocarbons, which are great, by the way, easy to store. Right. You put a gallon of gasoline in the corner. When you come back next month, it's still a gallon of gasoline. It's not some kind of crazy capacitor battery thing and the whatever. Right?
Yeah. It's great. I mean, you make it, you refine it as you need it, and then when you refine it, you can use it for a while, etc. So so actually you are correct, Ike. Yeah, it's because of these Western countries who, the mom
I
that
think
thinks
nuclear is the way. I think F that, go for nuclear and screw the Western sanctions in that regard. Like maybe, for example, in Niger, you're like, hey, number one, I'm going to make the right kinds of connections. As you mentioned, I have some minerals. Okay. I'm a small country. I have some minerals. Alliances are inevitable. Okay. I'm going to try to wipe the slate clean with regards to the way I view these people. I have interests. I work with the Chinese. I work with Russians and whatnot. Okay. But also, I'm going to build the first nuclear power plant over here in West Africa, something like that, right? And let me know your thoughts on that. But shout out to the super chat.
America First Rifle Kun says, please go a bit deeper in any news in Africa, electrification plan or project. Keep it up. Much love to Ike and Isaac. Shout out to you, brother.
Shout out to the NIMBYism being or NIMBY being not in my backyard. People talk about, oh, I want windmills, but not in my backyard, right? I want things to be my backyard to be clear. But I'm going to scream about windmills and stuff and so on and so forth. But like, what do you think about nuclear from a practical standpoint, and also in continuation of what you would do if you are in the position of Niger right now?
Right. Okay, great. So I'm gonna nuclear as well as Niger, what we'll do, and also the brother's question about general electrification plans for Africa. So nuclear is great for countries that don't have large hydro power source. For example, countries just don't have it, right? But countries like Congo, Ethiopia, etc., these countries have large rivers that actually can generate a lot of power in a sustainable way. So I'll suggest countries with hydro power technology potential, like the Congo Basin can power up the whole continent if you build a large enough hydro power station. And Ethiopia is now actually giving Kenya a lot of its electricity. We have a geothermal system over here. That's also another one that's pretty good. But the problem with geothermal, it's expensive. It's going to take you a long time to get the money back. Kenya is only now beginning to get its money back from the investments. So you do need that long-term mentality in order to build stuff like nuclear or geothermal. They are expensive as initial investment portfolios. And I think that's one of the reasons why African countries don't do it. They don't have the upfront money, billions of dollars to actually to do it. And some of the deals they make, because they don't have the skilled professionals to run it, are going to be basically more expensive than it is, let's say, for European countries. And in terms of Niger, electricity-wise, they are thinking about bringing Koreans and Russians and Chinese to help them sort of create an electrification. They're not really looking to nuclear, though, enough. They're looking more into... When you say
geothermal is over here, what do you mean?
Can you repeat that?
I think D in the chat is asking for you to specify geothermal power. Where it is.
Iceland. Right. Okay. So whenever you go deep underground, you'll find a few things. You'll find water sources, and also you find heat, right? Because the Earth's core is radiating a lot of heat.
But you aren't okay. But it's not so far.
Oh, it's
how
the
many
same stuff as
countries
hydro, really.
are
All it
taking advantage of this geothermal power thing?
right. Not many countries are. It is actually very good. It's reliable. It's sustainable, and you just have to have enough of the mining technologies to actually go deep, dig deep down, and build these water. It's all the stuff, steam engines. So it's the same stuff as hydro. Hydro doesn't actually need a steam engine most of the time,
Okay,
but yeah,
so
it's a
if you
steam
could
engine.
pause right there, and then if we just kind of took a few steps below with regards to that population increase that I was talking about, and then emerging markets, and just simply from the population standpoint, okay, from the demographic standpoint, and the fact that there are problems to be solved. There, the people will need cement, they'll need plastic, even more and more, right? Even just simply from a population growth standpoint, okay? Forget, oh, they're going to get richer, right? Because that's a type of bet that you have to make with regards to going into any kind of, you're like, hey, is the middle class going to be growing in this area? Is my business going to grow as a result? But okay, you're in a particular area where there is need for certain things, okay? And population is going to grow, right? However, it is a difficult place to go to. Okay, this pivot now is to talk about people who try to go, let's say, to Africa, try to set up a business. There, it's the wild, wild west. Systems are not set up. They get scammed by some real estate agent that had a shingle up in some sketchy part of town. Some guy called Usman, whatever, right? And so on and so forth. Okay, and
Right.
they go there and then they get disillusioned, and so on and so on and so on. But here I am saying that, hey, within the next 15, 20 years, set up something even simple is going to benefit from population growth, right? Blah blah blah. So, but how does one go about doing that in an emerging market where those systems do not exist? Systems that protect you, such as 1-800 whomever your favorite lawyer is that is gonna sue or whatever. But anyways, go ahead if that makes sense.
Yeah. So if you're gonna okay, Africa in general, right? And there are different levels of Africa as well, right? There's an index called ease of doing business. You can look it up. You can rank order the countries in Africa to kind of see where the risks and returns match your cost benefit analysis, right? So check it out, ease of doing business index. Now, that said, right, all countries are not born equal in Africa. What you could do is you find countries that are great for investment, right? Where more or less you're somewhat protected in a general sense. Countries like Rwanda, you are protected. Countries like South Africa, Kenya, to an extent, you are protected by certain systems where you're not just going to get scammed easily when you put money into these businesses. Now, the thing is though, if you do business in Africa, one advice I would give is don't trust anyone, right? You need to actually go on the ground, and this is a must, right? You need to go on the ground, or have someone you've been working with in the US who will go in the ground, who you actually trust in a practical sense, to go in the ground, survey the environment, survey the general business sense, survey the specific business you want to get into, and then you and that person that you have historical allegiance with in a practical sense of successful business, you guys do it yourselves, right? One of the problems with the pioneering in and venturing into Africa in general, this is true in any case, but in Africa specifically, when you set up a business, let's say you want to set up a poultry business, right? With the emergence of, Ike explained, human population growth and etc. Just by setting up a successful farm, again, land is cheap in Africa. You can find very cheap land in specific places. If you've got transport, then that's no longer a problem, etc. Let's say you get cheap land, you fence it, you build the chicken houses, you build the areas for the goats, the cows, and free range chickens, right? You set up a successful farm. You even get contracts with KFC and all these other companies. It's irrelevant. The problem in Africa is this, right? You're going to train people to do their job a certain specific way. You know why you have to vaccinate the chickens 3 times a day with exactly 5 milligrams of this specific antibiotic. You know exactly why you don't want these people coming in from the outside without fully disinfecting themselves, right? There's a whole system, there's a whole flow, there's a whole process that are directly linked to these chickens or animals getting sick. And you know this for a fact. The people are not going to look at that. The people are going to be like, yeah, I haven't touched anything today. Okay, they're going to come into your chicken house and bring a disease and kill everything. These people are not going to vaccinate 3 times. They're like, oh, but it's okay today. It didn't die last week. Okay, they're going to start using their own reasoning capacity, which is not transtemporal. It's not linked towards a business sense to reason, and then they're going to mess up your business. What I'm trying to say is, if you want to do business in Africa, it's great. You will make a lot of money. But
well, two things. First of all, and you may or may not land your plane, but you have to have some business acumen already. You have to have business acumen. Preferably, you already have to kind of have something going and understand how business works, because you're talking about an environment that is more difficult to operate in. It's not easier to operate in the Wild West, right? So, first of all, have some business acumen, and then you'll be able to avoid a lot of kind of issues regarding understanding how an operation actually works versus doesn't. And then to solve the second problem that you brought up, or to solve the problem about people not following certain standards, you're going to find the right person, which you already mentioned before with regards to maybe the business setup or the partnerships and whatnot, and you're going to pay that person enough to incentivize them. You're going to find the right type of person. In other words, it's going to be few and far between, but the type of person that's going to enforce certain standards, blah, blah, blah. Pay them enough, and typically things should run well in that regard. But yeah, you go ahead and land your plane.
Yeah, exactly. Find someone who you pay well, and you train. Right? Training is when you say training is not, and I think this is where you mentioned about business acumen, right? To people listening, they think training is following the standards of the country. Okay, we pay people this amount, $100 a month. No, you don't do that. You pay them $250. Okay. When you train them, you don't just show them what to do. You show them what to do, then you test them every week. You ask them how they did it. You have cameras and recordings so that you can check at every opportune time on your calendar. Are they vaccinating properly? Are they going through this system that I've created that's autonomous? So you come in through this room, you get your clothes off,
and create incentive structures around that. Like, if they're going through particular routine, like have certain awards. Oh, this person had the most safe days. This other person had the least blah, blah, blah. This person had the best such and such and such with regards to this other test, right? And therefore, they're getting, a 5% raise every 9 months. Yeah, why not? Because the business will succeed, things will work, and you want it to work, and these people will be loyal. It's not like, oh, United States, where they're like, oh, they're looking to jump to their next job in the next poultry farm over. No,
because in this case, the next job will work.
You're paying them more. Yeah, you're paying them way more than what they could get elsewhere, right? That is the trick.
Yeah, exactly. That's the only way you're going to do it. You have to create a game. You have to gamify things, and you have to pay them more than the local market, and you have to treat them well, right? But with Africans, of course, you can't be too friendly, because then now there's a concept of kuzoea, at least in Kiswahili, which means getting used to something. So their behavior starts kind of being a little bit too unreliable with you, because now they feel you're a family or friend, etc. So that line has to be instantiated. It shouldn't be crossed often. Otherwise, you also fail in that area. But you can't be mean, because if you're mean, people are gonna feel like they can screw you over, because you're just like all the people that abuse them.
Okay, so let's go back to the political entrepreneurialism aspect of things. Okay, as we maybe start landing the plane here for this stream. Shout out to the super chatter again, American Rifle Coon, I believe you called him.
Yeah.
The Rifle Coon himself. Shout out to you. Now, political entrepreneurism, we already gave you the the example of Niger. If you were in that situation, what would you do? Here's what you've got. You're a small country. You have this particular mineral. We talked about the makeup of the populace of the continent and the kind of political system that is most amenable to kind of working such a population, right? A population that is, in your words, not transtemporally focused. And a couple of things were said, and then you said, no, these people also are not they're not out from underneath the colonial, kind of French stuff. Now, but what is the path forward? Okay. I see that there's the technology path, which is okay. You can go out there, you can figure out the next thing, or you can start building these nuclear plants to solve that one aspect of your problems. Energy is a huge deal, right? Energy, if you drop the marginal cost of energy production in the population, in a dynamic population, and an entrepreneurial population, which is Nigeria, for example, who knows, right? These exponential and unexpected things do happen. That's one path, right? The technological breakthrough slash maybe don't kill yourself politically, just kind of stay alive politically, and then make a technological breakthrough. And then there's the kind of like the political path. In other words, like actually people start somehow finding a better way of governing themselves without in this kind of a way which we would call less corrupt, right? In other words, find a way to balance out this tribalism which needs to nepotism and a particular way of doing things, which is about it's who you know, right? These are kind of tribal, or as you call them, indigenous people tend to have this type of corruption. Okay, in Arab country, they call it bakshish, or you pay. In Afghanistan, it's there. In Iraq, there's these cultures that are tribal are about who you know, right? It's not about the indifferent line at the DMV, which is a bureaucracy. It's about if you know somebody at the DMV or if you know somebody or blah blah. Anyways, so which path, right? Are you gonna try to create the next super weapon? You're gonna Oppenheimer your way out of this, Mr. Empire?
Yeah. Yeah. So great question. So if I'm Niger, I think I have to look at things logically and cost benefit and leverage analysis, right? I don't have a greatly educated populace. I don't have hospitals. I don't have most of what it takes to sort of go down that great technological advancement in anytime soon. But what I do have is I have leverages of resources. I've got uranium, I've got coal, I've got gold, I've got iron, I've got tin, I've got phosphates, petroleum, molybdenum, salt, and gypsums, right? If I have all these things in Niger, what I'll do is in each of these specific industries that I have large reservoirs of these products, I would make sure that I only invite people that create factories with, like, as I mentioned, with at least 50% local workforce at every level, right? At the top all the way to bottom level, 50% my people in there, right? For skills exchange in each of these sectors. The factory as well, I would make sure that it's not their factory. I own shares in those factories, and I would actually be sort of creating pseudo government private companies that actually work with these other companies, like subsidiaries. I would make tax-free incentives as well for these countries, right? Because instead of focusing short term, okay, well, they're going to pay tax to me in dollars. I need that money to, improve my economy and all that stuff. I would actually reduce the taxes, right? As long as the money is coming back through the sale and also production of these materials, I'm going to be focusing on that, and also the long term trickle down effects of a higher trained, skilled, and let's say educationally proficient society. That's the path I would take as Niger, right? If I was a different country in Africa, like Nigeria or Kenya, I'll take a different route, because politically they're in different situation. They're more neutral towards Russia, the West, China, etc. They can now leverage and play both sides because they're in a slightly different political leveraging aspect.
A word on the currency issue. So how do we create this intra-continental trade? Not for stupid kumbaya hotep reasons, but
yeah,
such that, because okay, how do you do that, right? Now, in a very crude kind of way, you need things to move, right? And currency is the means by which you kind of move this kind of labor and capital and the factors of production, and the dollar is the way in which you do things across borders, right? Hey, Kaizo, I'm going to buy X amount of uranium from you. It's going to be done in dollars because that's a well-known third party. Okay. For all kinds, you can get into all the reasons why and how. Oh, is it the military? Is it the blah, blah, whatever, right? But that's what it is. Now, the way in which we could change that is if we all knew somehow, find a way to understand the balances of the thermodynamic flow, right? In other words, the movement of goods, populations and dollars and value amongst the geographical location in Africa there would not require this third party dollars if you're just exchanging. If you think of it as almost like a barter type system where you give me the uranium because I know that I always will be getting, I don't know, some fish from you, I don't know, some crap like that. That it will be the only way to get out of the dollar system, correct?
Yeah, yeah, exactly. But I also, like, I don't think you gave the problem why the dollar system is bad. I mean, what's wrong with using dollars?
Well, what's wrong with using dollars is because you are under the boot of
Of
the
the
central
of the
government. What? I'm sorry. Go ahead.
I said of the I didn't finish.
You're under the boot of the Fed, their interest rates, their whatever they want to do with regards to their currency,
Yep.
and in order
Whether
for
they
you,
print any more, whether you can easily get access to it when you need to use it, all that stuff.
yeah, and it can be again a weapon. You can face
Yep.
sanctions, right? Just such as
Yep.
the Russians and so on and so forth. They have the SWIFT system and all those other kinds of things. Which, by the way, cryptocurrencies and the blockchain in general might be a good, interesting thing. By 2025, let's see where it is. Probably
Mhm.
Bitcoin should be around 80K at least, stable at 80K by then. I'm predicting. I think 4x from here in the next 3 years. But
Yep.
anyways,
Yeah. So what Dean said, leverage, right? You don't want to be in a situation whereby you don't have the leverage, more or less. That's why the dollar sucks, right? Like right now, certain African countries are sanctioned by America, such as Zimbabwe. Uganda is now sanctioned as well for its anti let's get busy together laws that they impose recently, etc. So, okay, cool. We know the problem. So some of the solutions, as you stated there, of course, they are relevant, right? A barter system is going to be far more, let's say, reliable as a trade currency because you're not relying on external sources to provide you the currency. And whether you can even, and the issue here also, you have to earn the currency. You don't just apply to America and say, "Hey, America, give me this on the currencies." No, you have to earn it. That means you have to sell resources. You have to grow cash crops, and instead of growing these cash crops, you could be growing food for your population, etc. So, and evolving in that manner. So the method that you've described would actually require a coordinated effort, but not a very difficult one, right? So an example is, hey, a PhD scholarship for studying and getting information from all the companies and port authorities. How much of each, this information is kind of readily available, right? But if you're going to do this, you have to do it the right way, right? How much of each of these products, from the largest to the smallest, are traded yearly? And if you can get a backlog of this information for the last 50 years, then see if there's a trend, like a stabilized trend. You can use this to project the ledgers. For example, right, if Niger is exporting to Nigeria a total of $2 billion worth of let's say processed gasoline, okay, Nigeria then also exports to Niger $2 billion worth of electricity. They can simply use the ledger system over there to balance the sheets on the trade. And that will solve a lot of the problems, because at the end of the day, what are you trading? It's not the money, it's the
I
goods
think
and
it could
services.
probably also be open to even speculation, and in other words, I can see where you're trading futures,
Course,
of
yeah.
like the Nigerian electricity versus, yeah. So
Yeah,
it-
growth
yeah,
rate and all that stuff, right?
yes, where okay. So you're saying that is an important component. It requires a high level of coordination in order to happen, right? It most likely will not happen, right?
No, it won't, right? Because first of all, Africans, we're not intuitive, we're sensors, and we don't know how to fix our own problems, so it's not going to happen. But that would be the best case if it did happen, because we have to
All
be
right.
realistic about stuff.
On that note of realism, ladies and gentlemen, I don't know. We're going to kind of give our closing thoughts here. Our closing thoughts as we meandered through the unification of gravity, right? General relativity, that is, and quantum mechanics, and the frontiers of theoretical physics and the mistakes being made and all the billions of dollars spent in string theory leading nowhere besides giving us some mathematical insights. Started out talking about this superconductor at room temperature. Okay, that's the key point: room temperature and room pressure. 1 atmosphere, 14 pounds per square inch. All right, and around room temperature, superconductivity, whereby a material allows the flow of direct current with no resistance or minimal resistance, approaching zero resistance. And this has many, many benefits. There are many, many things that are yet to be done in the area of material sciences, many billions to be opened. The general premise here is that there have been a lot of advancements in the computer sphere, in Twitter and Facebook and all these. Now, tech, right? When I say tech, D in the chat, when I say tech, people think of computers, right? They don't think of
Yeah.
flying cars. They don't think of some kind of crazy battery energy, whatever. They don't think of these things. They think of computers. They think of zeros and ones. Tech has become that. It's like, oh, you're in tech. I'm in tech, IT, tech, right? So, and that's because that's the only area where we've really been seeing. So basically, I'm saying there's a lot of opportunity in the other side. We've been seeing a lot of development in zeros and ones, but there's a lot of development yet to be made in the realm of atoms, in the realm of the material, and we're breaking some frontiers in that regard. And the experiments are not very difficult to do. The understanding is not very difficult, so on and so forth. And what are the geopolitical conditions and the tectonic plates that will have to move and make such predictions and whatnot? And how does the average individual take advantage of any of this stuff, if possible, ladies and gentlemen? But what are your closing thoughts?
Yeah. So shout out to you and your points there. I would say, the average individual here right now, right, what they can do, right, especially if you want to prove me wrong that Africans can do transtemporal reasoning, is go ahead and find ways to get funding and build Afrocentric research centers, right? Whether you're Black American or African or anything, or indigenous or whatever, or some kind of minority, go ahead and do this, right? Right now, as I just mentioned, there is a missing link between technology, right? When people say technology, people think computers, but they don't even think of computers. They think of software, right? Even when I was like the technology field, I was like, to me, that's not even tech. That's just a bunch of software, right? Tech to me has always been that robot stuff, right? Stuff that's actually,
When these
transversing
coders
material.
call themselves engineers, man.
Right, exactly. Software people calling
So
these are
a
not
computer
engineers.
engineer is someone who understands the
Exactly.
computer circuit
Fundamental.
and understands
Yeah.
material sciences,
Mhm.
understands the
Yep.
fundamental of the electromagnetic field and
Yep.
all the
Yep.
Gaussian stuff going on in there. That is
Yeah.
an
That's
engineer,
right.
not somebody who codes stuff.
Exactly.
But anyways,
Exactly. A coder is not an engineer. That's a technician at best, right? Not an engineer. Engineering is not that. Anyway, so apart from that, right, I'll say this. Right now, there is a missing link in technology, right? And it's materials. If you can get the money, get the right people in hand, apply for the right funds. I mean, these again, there is funds and resources you can apply for if you're connected to certain institutions, right? You can spend your time and go and apply for funds and research grants and all that stuff, right? So if you're from one of the HSBCUs, that's the kind of stuff that you should be doing, right? Instead of just coming online and talking about how racism is everywhere. Go and do something about it, right? I know you won't do it because ultimately you don't want change. You just want to talk about how sad reality is, but that's a separate issue. I'll say, yeah, there's a missing link. Let's do it. Let's think beyond time and not just real time, and let's get it.
in the den of iniquity, vicinity no pretty. All right, ladies and gentlemen, that's it. We're out. Let's do a little we brought it in with the J. Ibrahim talking about young man and stuff. Uh
in the den of iniquity. Vicinity no pretty, calamity fi hit we any moment. What a pity. Tomorrow never certain. What dwells behind the curtain? The face of evil lurking with that shifty eyes averting. It's not a steady bubble that either pop or topple. Many will fall and stumble. Let the dozers gather rubble. From LA to Colorado, Guinea to Burkina Faso. Cannon could breach the towers and the troops will storm the castle. I say, run, run, come, make we get it. Because the peace that is bestowed upon the meek is overrated. So run, run, come, make me get it. Calling all your daughters and your sons, we come forget it. I say, run, run, come, make me get it. Because the peace that is bestowed upon the meek is overrated. Lord, run, run, come, make we get it. Calling all your daughters and your sons, we come forget it. With the rubble steady rising, and hearts are compromising. Convictions here are stifling, making evil appetizing. The fists are steady forming, and countenance is falling. Defenses are withdrawing, possibilities are falling. In these circumstances, evil will make advances. Pick up your sword and lances, and be sure to take your stances. Victory is never promised, the battle is upon us. Gather the brave and honest, and the righteous in your corners.